I am Dr. N. Satyashila, Assistant Professor, Department of ECE, Rohini College of Engineering and Technology. Course code 24EC 304. Course name Electronic Devices for Industrial Applications. Unit 4 Power Control Devices and Industrial Circuit Protection. The topic we are going to discuss today is silicon controlled rectifier. On completion, the students will able to know the construction, working and applications of SCR, circuit design using SCR, SCR construction and working. An SCR is a 3-terminal, 3-junction and 4-layer semiconductor device that is used to perform switching functions in power circuits. Construction of SCR. The SCR has 3 PN junctions and 4 layers of P and N type semiconductor joined alternatively to get PN-PN device. The 3 terminals are taken, one from outer P type layer called anode, second from the outer N type layer called cathode, and the third from the internal P type layer called gate. The structure and symbol of SCR is shown here. Working of SCR. In a SCR, the load is connected in series with the anode. The anode is always kept positive with respect to cathode. When gate is open circuited, when no voltage is applied to the gate terminal, junction J2 is reverse biased and the junctions J1 and J3 are forward biased. Since one of the 3 junction is reverse biased, so there is no current can flow through the load, hence the SCR is off. If the applied voltage is gradually increased, when it reaches a stage when reverse bias junction J2 breaks down, the SCR now starts conducting and become on. The value of applied voltage at which the reverse biased junction breaks down and the SCR become on is known as breakover voltage. When gate is positive with respect to cathode. The diagram is shown here. The SCR can be turned on at smaller applied voltage by the application of a small positive voltage at the gate terminal. When gate voltage is applied, the junction J3 is forward biased and junction J2 is reverse biased. Thus, the electrons from N-type layer starts moving across the junction J3 towards P-type material and the holes from P-type material moves towards the N-type material. Due to the movement of holes and electrons across the junction J3, the gate current starts flowing. Because of gate current, the anode current increases. The increased anode current makes the more electrons available at the junction J2. As a result of this process, in a small time, the junction J2 breaks down and the SCR is turned on. Parameters of SCR. Breakover voltage. It is the minimum value of the applied voltage at which the SCR is turned on, provided the gate voltage is not applied. For commercial available SCRs, the range of breakover voltage is 50 volt to 500 volt. Peak reverse voltage. It is the maximum reverse voltage that can be applied to the SCR without conducting in the reverse direction. The commercially available SCR have peak reverse voltage up to 2.5 kV. Holding current. When gate begins open, it is the maximum value of anode current at which SCR is turned off from on state. Forward current rating. It is the maximum value of the anode current that an SCR can pass through it without destruction. Current fusing rate. It indicates the maximum forward surge current capability of the SCR. It is defined as the product of square of forward surge current and the time duration of the surge. Applications of SCR. SCR can be used in power switching circuit, controlled rectifier, AC power control circuits, speed control of DC shunt motor, SCR crowbar, computer logic circuits.